Lesson 25, differentiating between relations and functions. So a relation is just a set of ordered pairs, and each number in the domain is matched to one or more numbers in the range. So a relation is a set of ordered pairs. Each number in the domain is matched to one or more numbers in the range. Well, let's go over what domain and range are next. So the domain are all the possible x values. It's the input number. It's the number that you put in. It's called the independent variable. So it's all the possible x values. It's also called the independent variable, or the input number. Now the range is what you get out after you pick the x value. So it's all the possible y values. It's called the dependent variable because it depends on what you picked for x. It's called the output. That's what you get when you input that value for x. So relations can be shown, relations can be represented, by a table, a graph, notation, diagram, and or an equation. So I'm going to show what a diagram looks like. So here's a diagram of a relation. We have a group of numbers for our input and a group of numbers for our output. So the numbers we're going to put on the input are 2, 3, 4, 5, and 6. And the output we're going to put 1, 6, 9, and 10. So we're going to match up 2 with 6, 3 with 10, 4 goes to 9, 5 goes to 9, and 6 goes to 1. So our domain is the input side. So on the left side is 2, 3, 4, 5, and 6. And our range is the output numbers 1, 6, 9, and 10. Remember that these are sets. So you use braces, you list the elements with commas between them, and that would be your domain and range. Now if we want to write them as ordered pairs, we would write our braces and we'd write them as points. So we have 2 with 6, so we would say 2, 6, or inputs 2, output 6, then put a comma. We have 3, 10, 4 goes to 9, 5 goes to 9, and 6 goes to 1. And then we end our brace. So this is as ordered pairs. Now a function is a type of relation and it has some rules. So we're going to write a type of relation. That pairs each value. So it's going to take each value in the domain with exactly one value in the range. So each x value, or the input value, is only allowed one y value. So these, this diagram up here, this does represent a function because every single domain is matched with one number in the range, just one. Even though 4 and 5 are both going to 9, that's okay, because 4 only goes to 9 and 5 only goes to 9. So here's an example. Brace, we're going to do ordered pairs, 1 and 7, 2 and 3, 9 paired with 5, 6 and 3, 4 and 9. This is a function, so yes, it is a function. Now, if we added a number, so let's say we added the point 2, 4. Notice that we already have a 2 input, and it's supposed to be 3. So in order to stay a function, you can only get 3 when you input 2. Well, if we add the point, the order pair 2, 4, it's no longer a function because now 2 is mapped to 3 and 4. So if we added that point, it would no longer be a function. So we have, sometimes we write our functions in function notation. That just means instead of using the letter y for your output, we're going to use f of x. So the way we read this is f of x. This is one of those cases where of does not mean multiply. It just means we are finding a function of x, which means we need x to find out what y is. So we're going to do an example here. So we want to write y minus 3 equals 5x in function form. So instead of writing the letter y, we just write the letter f of x. So f of x minus 3 equals 5x. And we solve for f of x the same way we do when we solve for x. We're going to add 3. And we get f of x equals 5x plus 3. Now here's an example where we're given a function and we're asked to find the output numbers for certain input numbers. So if f of x equals 6x plus 3, then find f of 2, f of 5, whoops, and f of negative 1. So we don't need a comma in here. Just need it to be, there we go. So f of 2, that just means we want x to be 2. So it's like substituting. So we'll do 6 times 2, and then we'll add 3. So we have 12 plus 3 is 15. F of 5 just says plug in 5 for x. So 6 times 5 is 30, plus we add 3 and we get 33. F of negative 1, we're just plugging in negative 1. So 6 times negative 1 is negative 6, plus 3 equals a negative 3. And that's the end of the lesson.